Hello and welcome to episode number 3 of how to make an operating system in Rust. Today we are going to I would say we start with println. So what we are going to do is yes, we're gonna start with the serial.rs. This one we are going to turn into a struct, which is going to take an uart adder of *mut8, and then we are going to put everything into an impl to I don't know, this. Is this gonna work? I don't know how this works, but okay, let's do the normal way. I'm not a Vim Pro, by the way. So, okay, now we have this. We are going to define a constructor. Just gonna return a self and instantiate uart adder *mut8, and this is gonna instantiate a uart. Okay, now we have this. And we are going to main. And now what we're gonna do is we will, that was not what I wanted to do. We will mod serial. We already have this. Okay, then we are going to say let s is equal to serial new with or serial address. And for that, we're gonna make a const serial adder *mut8, and that's gonna be equal to let's actually do this so that we can switch easy. So that is gonna be equal to or address here, and here we are also going to say self dot a *mut self, get the same thing. Okay. In main, we then are going to define our serial address. That is something for later, not what I wanted to do. Let's do serial adder. Okay. And now we should be able to do s dot puts I world. Not accessible, so we need to make our struct public. Cannot borrow. And it must be a *mut8. Okay. Oops, of course, an S. And this should still run. Very good. Now that we have this, next thing we are going to do is we are going to define our print macro. And for that, what we're gonna do is we're gonna export. So the first thing we need to do is we do a macro export, macro rules, and here we're gonna say kprint line. That's what our macro is gonna be called. And the macro is gonna take this thing. So this just means that the macro is gonna take a lot of a variable amount of arguments. Now what we're gonna do is we are going to define an inner scope, and here what we need for a print macro is the trait write format, which we are going to now implement on our struct. So how do we implement traits? We are going to go to our serial struct, and we are going to say impl write for serial, and then we will we'll use the write format function, the function that we need, and we're gonna say function write string takes a mutable self-reference and a string of type string slice, returns a result, and is gonna call on itself or serial bots function. Put string like this, and then we're just gonna return a result of OK, an empty OK value. Yes, this is the implementation of a write string trait. And now in the print we can say it should be fine if we just always for now create a serial console. So what we're going to do is we are going to let mute, let's call it console, and we are going to say that comes from create serial serial, then new, and here I will just hard code the address for now, not print of course, this one, and we're gonna use this. Okay, but this gives us a console. Now that we have a console, what we need to do is we are going to try to write to it. So we ignore the return value. We are saying write format, and then we format args. Format args macro is basically it takes a format string, or it not the format string. It takes in a special argument type that or it returns a special argument type that represents or actual string. So what we're gonna do is we are going to put just the same thing that we have up there. So every argument is going to be put into format args, and here we also need to use core format write. I haven't found any better way to do this, to import this into everything, but this seems to work, so we will keep it like that for now. So, and in theory, this should compile if we didn't do anything stupid. We mod print, keep this, and then we will kprint. It works. So now we try building. Of course, we need to use core format write in serial. So let's do that. Again, this comes later. We're almost there. I'm always struggling with copying and pasting. Maybe I will use like something else in the next episode. Yes. The result thing we also need to import. So what we're gonna do is we say result and write, and we're gonna put them into these curly braces to import both of them. Okay, we named it kPrintLn. Println comes later, so let's just name it kprint. Good. Okay, it prints hi world, but as we saw, it should actually print more. Why doesn't it print? It works. The reason for that is format args. How do I explain this? It takes a function pointer, and by default, Rust binaries are position independent, which basically means we need to relocate the code to use this feature. How do we do that? It's a little bit more complicated, a little bit more involved. So the first thing is we need to change some compiler flags. So that we go into our config.toml, and we're gonna add the following. We're gonna add C relocation model equals PIC, position independent code. Then C link arg equals -PIE. And the third one for the read-only fields, we're going to say link arg equals z no text. Okay. So now we instructed the compiler to generate position independent code, and they link it to also generate a position independent executable. What we now need to do is in our linker script, we have to specify the corresponding segment. How do we find out what segment we need? We can use something called readelf-a, and then or run it on our binary. We see lots and lots of things, but the important part here is the dynamic section, like relocations and dynamic sections. So relocation and dynamic sections, they are called .rela.dynamic, and the segment, the what's it called? The actual segment or whatever it's called in any object file, in any compilation unit, you get the rela section. So what we also need is we need a label for, let's call it rela start equals dot, and then rela end equals dot. These are the markers that we're going to use to read from this section. Okay, so let's try to recompile this. It recompiled it. Let's actually clean this completely and recompile it and run readelf on it again. And now we should see a relocatable section. So this means what we just did worked. And now we can write the code to actually relocate a binary at runtime. So this code is actually quite simple. I am gonna implement this in assembly actually to relocate a binary. First thing that we need is we need to, let's put it after here, we need to load into a register. Since we're gonna make this a function call, I guess I'm gonna let's see. I guess I'm gonna use the calling convention. So into x0, I'm gonna put the address of the start function. ADR should be fine here. Then ADR in x1, we're gonna put rela start. And in x2, we are gonna put rela end. I'm actually not sure if this is gonna work, but let's try this. Then we're gonna write a function that is called underscore relocate binary, I guess. So in this function, underscore relocate binary, we are going to say that we have, now comes the part that I accidentally been pasted the whole time, aarch64 relative 1027. So this is the type, and this enum is equal to 1027. What this relocations doing is basically it goes to the binary at the offset, and if it's a relative relocation, it is just gonna do it's just gonna add the end at the end to this offset, to the value at this offset. So what that basically means in code is we are going to, now let me think real quick. We have or start in x0 or relocation start and end in x1 and 2. What we want to do is we want to load a pair into, let's say, x7 and x8, and we are going to load it from x1. Then increment by 16 bytes, since each of those variables is a 8-byte variable. So then we are going to load the third field in relocations. I'm gonna put this in x9, and that is also gonna come from x1. And here we're just gonna increment by 8 after the load. Then the next thing is we are going to compare x8 with the or thing here. If that matches, then we will continue for now. If it doesn't matches, if it's not equal to this, yeah, we're just gonna branch to the end for now. And at the end, we're gonna return. If it matches, though, we are going to, let's see. What do we need to do? We need to add our base, which is in x0, to the offset to the base. So in x0 at the offset, which is in x7, which is here the first field. So it goes like offset, oops, sorry. It goes offset, type, and addend. So offset, type, addend. So we add to our base in x0 but we need to keep it actually. So we take x10, we add x0 and or add end, which would be x. No, we want our offset, which is x7. So here we say add offset to base. Then we add in x11 to the base or add end. Let me think. Do I want to add it to the base? Yes, because symbol name plus add-in, so it is both of it. So what we do is what is in x9 we are going to add to the base. So add-in plus symbol to base, and after that we can store or x11, so or relocated function pointer to or calculated offset in the binary. And then I want to compare whether x1 is equal to x2, which is or rela start and rela end. If it's not equal, I want to keep relocating. Let's see if this works. This is a little bit difficult to follow, but if we get a print, then it works, and we got a print. So this means we successfully relocated our binary right now, and we can now print everything that we want. So what we could do is kprint, and just like in normal Rust, we can now use format specifiers. Let's use this one, and let's actually print our s variable for a second. We do a build and run. Oh, okay, we need to derive debug for sure. So let's do that real quick. Derive debug. And look at that. It actually works. We can now print like in the normal Rust code. And what we're not gonna do now is in print, we are going to do the same thing. We are going to implement println now. It's basically the same thing. Macro, we want to export this macro. Then we also are going to do macro rules, a println. And now we can do a trick. We can say, if for this macro, we do not have any arguments, we're just gonna call our kprint macro with dash new line and a carriage return. Otherwise, if we have a lot of values, which is the same as up here, we have this, then we are going to still use kprint, but we are going to have two placeholders. I'm gonna use format args again, just like we did up there on no, I am lost, like this. We are going to use format arcs on or arc with like this. And then as second argument, we will just add our new line and a carriage return. So this was a lot to take in. So what were we doing? If we have no argument, we are just gonna call our kprint macro, this one, with a new line and carriage return. Here, we are going to give it 2 placeholders, and the first one is gonna format all the arguments for that we give it, and the second one is the addition of the new line. So if we now let's see what we did. A typo. Okay, so now what we're gonna do is we're gonna go into main and replace all of them with println and see if it works. And it's not working because kprint did not find kprint at root. Of course, create. I think we have to do create print tier 2. Oh, I made a typo here. Okay, print. Okay, then maybe that was a mistake that I had. Because it should be. Yes. Okay. And now everything works for us, which means now we can get rid of this and say kprint line hello world. Oh yeah. Take this away. Okay, now we have a kprint. What we can do now is we can make a better panic handler. So instead of just looping, what we can do for the panic handler is we can do a kprint line with let's see, panicked at the whatever we want. This no, actually let's put a new line here and then put this. And now we can put as an argument, let's take the info and say we panicked at info.location location.unwrap and info.message. Okay, now at the end we want to panic test. And let's see if this is gonna work. We made a typo again. a println, and there we go. Now we get source level information where we panicked. So main 34, and at the 5th character, and if we look at it, 34 5th character is this line. And I think that is enough for today. What did we do for now? For now we made a, so we changed our serial to be a structure that implements write string. Then we implemented the print macro. We noticed, oh, it doesn't work because the format args function uses function pointers that need to be relocated. Another trick how we can find this out in if we are dealing with relocations and stuff is if we do an object dump target as this. Okay, if we do an object dump and then we search for branch link register. So, and if we see like if we branch with link to some sort of register, like in this case x8, then we can be very sure that this is a relocated function pointer. So yeah, then after we did this, we noticed, of course, it doesn't work. We then implemented in the linker the dynamic relocation section, which gave us access to this information, the relocation information. And then in the relocation, in the compiler flags, we configured the compiler to create position independent code, the linker to actually generate the relocation flags, and we say no text, which is important for the row data relocations. Yeah, and after that, we finished with println, kprintline, and then we just implemented a debug on a serial interface, and we tested out our println and rewrote our panic handler. What we also can do now, just real quick, is we can tear this apart a little bit more. Like in the main, we can get the panic handler and make a panic.rs. I've done it again. So put the panic handler in here and get panic info. Let's do this again. Get panic info. Okay, that should be it. In main, we are going to delete the whole panic handler. We are going to delete this one. We're going to mod panic. And now it should still work. Did I use source print macro export? Oh, I didn't. To do macro use, what do we do? To do macro use, we have to go to the import in main, and say this one is macro use. Okay, I should stop pasting like this. And let's actually put this last then. Okay. Consider importing this macro. Wait, do I have to do this for every? Again, I didn't. Okay, do I have to do this for every single one? How does this work again? This is not it. Wait. Where did I put this? Mod print. I put this on the mod in my other files. I actually do not remember this error, but okay. On the module import. Should work. We do this. If it doesn't work, then I will research this for next episode, and then we will take a look. Okay, it doesn't work, but now we at least have a println macro that is going to aid us in debugging and everything. So I'm gonna fix this up real quick again, and then I will research why this does not work for me. Anyway, thank you for watching this episode. It's been 37 minutes again. That's actually quite a lot. And I hope you enjoyed this and this was useful for you. See you in the next episode.